Okay, summary of Chapter 7a, which is about polynomials. First thing to notice is that they have positive powers. So if variables have negative powers, or the variable is under the bottom of a fraction, which would make it a negative power, it is not a polynomial. Some key words, these are called terms, and they're broken up by the subtract and addition sign. And the little numbers can be called exponents or indices or powers. Having a look at these two equations, we're going to look at 4 parts of it. So first of all, in this first one, the leading term is the term with the highest power. So that is the x to the power of 3. So that's our leading term. So usually we would write that one out the front, but it doesn't matter, but it's just that it has the biggest power. The degree of the polynomial is 3, so that's the highest power, so that would be 3 as a degree for that polynomial. Is it a monic polynomial? That's if the coefficient in front of the leading term is 1, and it is, so yes, this is a monic polynomial. And the constant term is -5, so that's the term that doesn't have a variable. Looking at the second one, the leading term is this first one, 3x squared y cubed. The degree of the polynomial is an interesting one. It's actually 5. So if you have 2 together, it is 2 plus 3 is 5. So if you imagine your index laws, when you added them together, that's sort of what you're thinking for your degree of the polynomial. Is it a monic polynomial? That's if the coefficient of the leading term is 1. No, it's not. It's a 3. So it's not a monic polynomial, and the constant term in this one is +15. Okay, adding, subtracting and multiplying polynomials. So polynomials are functions, okay, so when they're on a graph we can do the vertical line test and it doesn't go through twice. If we have p of x is this and q of x is this function, when we add them we simply write the 2 out and add. Now the brackets don't really mean anything in this situation because we're just adding. So this is x cubed. There's no other x cubed. There's 3x squared plus 2x squared. And there's 2 plus 4, which is 6. When we're subtracting, the bracket becomes a little bit more important, only because we need to remember that we're going to take 2x squared and take away 4. And if those had subtraction signs in them, it may be subtraction of -4, which would be adding 4. So sometimes we need to think of that as multiplying everything in the second part by -1. In the last one, we're timesing. And here it's basically FOIL. They've written it out as this first function times the 2x squared and the first function times 4. Basically, you just need to think that each one of these is going to be times by everything in the second function. So x cubed by 2x squared, x cubed by 4. 3x squared by 2x squared, 3x squared times 4. 2 times 2x squared and 2 times 4. So it's just FOIL but with an extra element. We'll notice that when you're adding, subtracting and multiplying polynomials, your answer is a polynomial. Okay, so you'll see this fancy sentence in the textbook, and what it's talking about is the degree of a polynomial, which if you remember back from the start is the highest power in the polynomial. So this first one simply says that when you are adding, the biggest degree from f or the biggest degree from g, that will be the biggest degree in your resulting polynomial. If you are timesing f and g, you'll take the highest degree of f and you'll add it to the highest degree of g, and that will be the degree of your answer. So just as an example, so going back to this part, p of x had an x cubed in it and q of x only had an x squared. So when we added them together, the degree ended up being an x cubed. So that was the highest out of p and q. Now with subtraction, it seems to be a similar case, but of course you could have the situation where the x cubes actually cancel out, so we can't be certain that that one will have an x cubed in its answer. Now when we're timesing, the rule says that you will add the powers of both, so to add the highest power of both. So we can see that it was an x cubed and an x squared, so we should be getting an x to the power of the 5 in the answer. When they go through all their working out, yes, so the highest power is x to the power of 5. Okay, this is another fancy sentence for saying something very simple. If you have two polynomials and you want to say they are equal, then each of the coefficients has to be equal. So if p of x and q of x were to be equal and q of x had a 4 in front of its x cubed, q must have a 4 in front of its x cubed. And so I guess we'll use that later when two things are equal and we want to find the missing parts. We can say that this part is equal to this part. Okay, looking at expanding things, so some shortcuts. We should know by now that if we have our perfect square at the top here, we could just expand it using FOIL, but we know we'll end up with a squared plus 2ab plus b squared. So we also have some shortcuts for a plus b, and that's being cubed. So they've shown the long way here, but the answer we're looking for is here. So we end up with a cubed plus 3a squared b plus 3ab squared plus b cubed. Now remember that this squared here is only impacting that b, and that squared is only on the a. Unless there's brackets, it's not on both of those letters. So we end up with this new shortcut and this new shortcut. And later on, or in specialist maths, you'll look at a sort of a pattern and how to work those out. But for now, we just need to remember that that's the cubic one. So we've got the square and the cubic and the quartic. And look at my beautiful handwriting.